Good day to everyone. Thank you for joining us here today. And we are here to present a research paper entitled Lip Biometric Authentication using Viola-Jones and Appearance-Based Model or AAM System, prepared by the following members: SHARMANE Marigo, Julia Regala, and Linda Joyce YANO, with our beloved advisors, Engineer Ramon Garcia and Dr. Jennifer Dela Cruz, as well as our panelists. Before we begin, I'd like to introduce myself. My name is SHARMANE Go. Nowadays, face recognition is one of the extensively used biometric authentication systems that have been used in many applications, right from giving attendance in our organization to authentication purpose, and it is one of the fastest growing biometric technologies according to Forbes. A new study reports that facial recognition works better using standardized samples such as mugshot pictures or police department databases than with unconstrained images. Thus, we are able to use these findings in our paper.
Hi, my name is Julia Regala. I will be explaining the background of the study until the RRL. Background of the study. Facial recognition technology is often used in companies' customer service efforts, business events industry, wherein there is a need for visitor management system and identify the attendees by searching a database of faces in real time. Statement of the problem. Facial recognition technology's shortcomings become visible when it comes to similar-looking people, wherein there is a high probability of false identification on someone whose looks is very much a resemblance of another person. For the gap, the researchers have proposed a biometric system that focuses on the uniqueness of the parameters of the lips as a useful feature to distinguish similar-looking people. Our main objective is to develop a facial recognition system capable of distinguishing between similar-looking people. We have three specific objectives. First is to build a facial recognition hardware system. Second is to incorporate a software system through OpenCV by using Viola-Jones algorithm and AAM. Third is to test and to evaluate the performance of the system on identical twins and similar-looking people. Scope and delimitation. The focus of the study will be on developing a facial recognition hardware system for authentication purposes using image processing and image analysis. The features of the face are dynamic and can be temporarily altered by expression and contraction of the underlying musculature of the face. The study is limited to evaluate still face front images of subjects with neutral expressions, and other type of twins aside from identical twins will not be considered. This study limits its coverage in the Philippines only. Categorization of racial groups by reference to skin color plays an important role on facial recognition. The lighting within the scene may significantly impact the visibility of facial detail. Therefore, it is important to consider the right illumination to prevent errors due to the inconsistency of the light. Subjects under the age of 18 are not included because their distinct facial features may not have fully developed. Thus, the study focuses on the ages 18 and up. In the paper titled Analysis of Facial Features in Identical Twins, the authors have presented the facial features that are most distinctive to distinguish identical twins, and that twins became distinguishable after using the mouth component analysis. The paper titled An Analysis of the Viola-Jones Face Detection Algorithm, the authors have concluded that the Viola-Jones have a very high detection rate and that it reduces false positive rates. In a paper by J. Phillips, the author has explained how the support vector machines or SVM is applied to face recognition, and in a paper titled A Hybrid Algorithm of Facial Feature Point Location based on Improved MRASM and AAM, authors have concluded that the location results of eye, mouth, nose, and eyebrow for both algorithms are the best. OpenCV has provided a tutorial for the AAM. The tutorial will teach you three things. First is how to create the instance of the FaceMark AAM code. Second is to train the AAM model. And the last one is how the fit of the algorithm works. The guide has been divided into several parts. The first step is to set the instance of parameter for the algorithm. The default scaling factor is 1, meaning that no scaling will happen during the training. Adding 2 scaling factors, scale 2 and scale 4, will enable the user to train 2 more models. This will then lead to a faster fitting time. And to avoid losing important information for the landmark detection purpose, it is recommended to avoid setting the scaling factor too big. Next is to load the dataset and add the samples to the trainer. The dataset should be a dataset of facial landmarks detection, and the images from the dataset and its corresponding annotation data, such as the facial points, are loaded one by one. After adding the samples to the trainer, the algorithm will process all the annotation data. The trained model will be then saved to a specified file. This is a time-consuming process depending on the number of samples you train. And before testing, the parameters such as rotation and translation should be set. These initializing parameters can be obtained by comparing the trained model to the current face image. Comparing the angle of the line formed by the eyes will give you the rotation. Comparing the distance between the eyes of the current image to the trained model will give you the scaling. And the fitting process is started by detecting the face in a given image. If at least one face is found, then the next step is computing the initialization parameters. And after the fitting is finished, you can visualize the result using the draw face marks function of the OpenCV. This is the conceptual framework for our system. The input image would be the facial image of the subject, and that image will undergo the process of facial detection, feature extraction, comparison with predefined dataset, and differentiation. And the output would be the profile of the subject.
I'm YANO, and I will be discussing the hardware methodology. The hardware methodology falls under the first objective, which is to build a facial recognition hardware system. The following figure shows the wiring diagram of the hardware system.
Hi, I'm Julia. I will be discussing Chapter 3 of the software of our system. As mentioned before, the second specific objective is to incorporate a software component which utilizes a person's image and verify the identity through image processing. This is the general flowchart for the inquiry. By using the image from the camera, the image will undergo face detection, feature extraction, and classification. The system will then determine if there is a match on the database. If no, the process will end. If yes, the profile of the respondent will be shown on the screen. This is the general flowchart for the registration. After providing the necessary information, such as the name, birthday, and gender, the image of the user will undergo face detection and feature extraction. All the information of the user will be saved in the database upon completion. This is how the face detection works. First, the captured image serves as the input to the system, and before detecting a face, the input image is converted to grayscale as he equalized histogram so that there's lesser data to process. Then the algorithm scans the input image by creating window-looking boxes, which acts as a detector that is capable of detecting features of human face. The detector constructed contains rectangular boxes with HOR-like features, which will be matched from the histogram. Following the feature extraction algorithm from our related literature, the HOR-like features can be calculated faster by using the concept of integral image. The histogram of oriented gradient is used to extract facial texture of the input image. Lastly, if the extracted features are located and have a specific value such as face, that window is estimated to be a face. This study utilizes AAM method to extract the location of points on an image. The shape is determined by considering a training set of sample shapes. The points will be converted into their representative forms, which will be used for parameterization. These parameterized key points will give the face information for the recognition system. The figures on the right are samples of feature extractions with its corresponding points and coordinates and its linear shape models. The table on the right shows the coordinates for the points in a figure on the bottom right. Points that have the same coordinates are highlighted in yellow. Are samples from our database for feature extraction for similar faces, identical twins, and similar faces. This is what our GUI looks like. For the home screen, the screen shows two buttons that directs you to another screen depending if the user wants to inquire or wants to register. For the registration screen, the user will be asked to have his his or her photo taken for the database, which will be saved after clicking the capture button. The user is also required to fill out the forms to identify them. For the inquiry screen, the user will be asked to have his or her photo taken, which will be used to find out whether that person is registered or not. What our GUI looks like when the person is recognized and when the person is rejected. When the person is recognized, the details of that person will be flashed on the screen. As mentioned before, it is important to consider the right illumination to prevent errors due to the inconsistency of the light and the proper distance to max out the best condition to use as parameters for the controlled and uncontrolled testing. The ring light has 3 different settings for light: white light, yellow light, and white-orange light. Through this experiment, the best distance from the camera is 20 inches using white light.
For the testing, we ensured that the respondents for the training will have a neutral expression to lessen the obstructions that will hinder from obtaining accurate data for the study. Once ready, the test subject will be asked to have their pictures taken. For Objective 3, this study aims to test and to evaluate the performance of the system on identical twins and similar-looking persons. The table shows the result of the sample testing data analysis for controlled testing, wherein the acceptable confidence level will be determined. Confidence level refers to the probability that the value of a parameter falls within a specified range of values. The probability values are the raw values from each sample taken for 2 trials from the confidence level. The mean is necessary for the confidence and can be computed by getting the average of the probability scores for 2 trials. We have 0.941381 as our acceptable confidence. In this uncontrolled testing, the samples in this table were taken randomly. Since the accepted confidence level have been determined during the controlled testing, which is 0.941381, the system will be able to determine whether the capture image is accepted or rejected by the system. In this case, the result will be match or reject. From the table, samples 7 and 8 were also rejected because it does not meet the 0.941381 accepted confidence.
My name is JOYCE, and I will be discussing about the testing for accuracy using confusion matrix. To test the accuracy of the software, confusion matrix was used. Since the system qualifies as a binary classifier having 2 outputs, which is the matched and unmatched, we have used the following format of confusion matrix. Different parameters were measured, and they are as follows. True positive, wherein the system accepted or verified the identity of the subject and his or her data is really included in the dataset. True negative is when the system rejects the claim of the subject because they are really not included in the dataset. False positive is when the system accepted the claim of the subject when it shouldn't have. As for the false negative, it is when the system rejects the claim of the user. Performance measures like accuracy, precision, and recall were measured. Accuracy is computed by dividing the number of all correct predictions. Precision talks about how precise or accurate your model is out of those predicted positive, and is computed by the number of correct positive predictions divided by the total number of positive predictions. Lastly, recall or sensitivity is the ratio of correct positive prediction to the total number of positive. For the conclusion, this research has utilized the parameters of LIPS for a facial recognition system using Viola-Jones and active appearance model algorithm. For the uncontrolled testing, adding more samples to the dataset may produce some false negatives, since 3 of the subjects that were initially accepted during the controlled testing were rejected for uncontrolled due to the set confidence level. The accuracy of the system were computed using confusion matrix, obtaining at least 87.5% accuracy overall, which is the ratio of all correct predictions divided by the total number of samples. For the recommendation for future studies, they could consider the parameter of other combination of facial components, for example, the facial marks and eyes. And also, for the further improvement of the training of images, a huge database can be worked on.
We would like to thank God for giving us strength, capacity, opportunity for partaking and earning knowledge from this thesis study. The accomplishment of this study would not be possible if without the help and guidance from many people, such that we would like to extend our gratitude to the organization of the colloquium. Without you, this colloquium would not be possible. We would also like to express our deepest gratitude to our advisors, Engineer Ramon Garcia and Dr. Jennifer Dela Cruz, for imparting knowledge on the research topic, providing guidelines during the course of study, and for being most accommodating and considerate to our group. We would also like to acknowledge the constructive ideas expressed by our panel members, Engineer Julius Sese, Engineer Glenn Maguili, and Engineer Leonardo Valiente. Your suggestions gave room to improvements in our study. Lastly, we heartily thank our parents, family, and friends who gave us encouragement and support which helped us greatly in the completion of this study.